Hello and welcome. Let me see if that works. It looks good. It's looking good. I think you can hear. I hope you can hear me. Hey, hello everyone. Again. Okay. All right. Let's settle down again. All right. Hello everyone. My name is Dennis. I'm a developer advocate at Amazon Web Services. I used to be a software engineer and a solutions architect for many years, and now I'm going to show you how to build things on AWS. This is the 5th episode of a live stream where I walk through the creation of an application. However, it doesn't really matter if you missed the first 4 episodes because I think today we're going to talk about something that can really be seen somewhat isolated. Today we are going to create a Dynamodb table and use a Lambda function to write into that Dynamodb table. And in order to do that, we have to think about a few things like data modeling, like cost, execution time, and so forth. So there will be a few very interesting things that we're going to talk about. And what's interesting and also important to note here, I didn't prepare this. So we are really walking through the same thing, or you're coming along with me as I go. So we'll look at the documentation. Maybe some things that I intend to do don't work the way I want them to. So this is like in real life where you have to find out how things work. And I hope this will be a helpful learning experience for you while you're watching me. Hey, Jemmy, nice. Thanks for joining the stream. How are you? So just real quick, I'll run through what we did in the past few episodes just to get you up to speed. And for that, I've got my pen and my tablet here, and I hope that it works. Let me see. Let me pull up my screen. Oh, that's the wrong one. This one. Let me pull up my screen real quick. So this is very dark right now, but that doesn't matter. That is intentional. And let me see now. Where's my... Here we go. All right. So can we pay? Okay, cool. That works. So what we did in the past few episodes is we built an application with a few moving parts. What we want to do is whenever we upload a new file with YouTube statistics, so that's our YouTube stats. Whenever we upload a new file, we want to process the file. This is a CSV, a comma-separated value file. We want to process that into a Dynamodb table. That's what we want to do. So whenever somebody uploads a new file, we want to go through the file and process each item inside of the file into a Dynamodb table. That's the thing from a business perspective. The technical implementation is that we have I can't draw. Give me a second. So the technical implementation will be an S3 bucket. And this file, once it's being uploaded into S3, it will trigger an event which automatically triggers a process. Which does some things and eventually stores the data into Dynamodb. And this process is a step function state machine. It's a step function state machine, and this might be a Lambda function down here. This could be a Lambda function that writes the data into Dynamodb. What we already did in the past few episodes is all of that. So we have the bucket, we have the event notification, we trigger a step function state machine, and the step function state machine triggers a Lambda function. And we've built all that using the AWS CDK, the Cloud Development Kit, using infrastructure as code. And what we're going to do today is basically work on this part. And let me see if I can change the color. There's some way to change the color, I think. Yeah, let me use this one. Here we go. All right, so what we're going to do today is really build this part. First of all, we need a DynamoDB table. DynamoDB table. First of all. Second, the Lambda function should write to the table. And that's the two things that we're going to do today. We'll make sure that the existing Lambda function that we already have writes the data that it retrieves from the file into the newly created DynamoDB table. And if you have any questions, please let me know in the chat. For everyone who's just joined, my name is Dennis. I'm a developer advocate. I work at Amazon Web Services. And in this series, we are just coding live a piece of an application, a small application using AWS services, using things like Lambda functions, step functions, state machines, S3, event triggers, DynamoDB. And we're building all that using the AWS CDK. And we're, as an IDE, we are using the internal IDE inside of AWS Cloud9, which is right here. And I'm going to pull that up to make it a little bit bigger. And as I said, if you have any questions, please let me know. And please don't forget to subscribe to like this video if you like it, if it's helpful to you. And if you want to learn more about AWS, feel free to subscribe. So, all right, here we go. To start, we have, I'll start real slowly. So right here, we're in the AWS Management Console, and we do have a service called Cloud9. Cloud9 is an IDE, an integrated development environment inside of AWS. However, you can use anything you want. You could use IntelliJ or Visual Studio or Visual Studio Code or PyCharm or whatever you want. In this case, I'm just using the IDE that is built into AWS. And you can see in here, we do have a number of things already. We already built a number of files inside of our application, but that doesn't really matter right now. What we want to do is take this file. This is an example file of my data from YouTube. These are my YouTube statistics from this channel that you're watching right now. And I want to take all the lines inside of this file and store them in a specific way in a DynamoDB table. And that's what this is about. And whenever somebody uploads a new version of this file with new statistics, I want the data in DynamoDB to be updated. So I'll just make sure, because we're using Python, I'll make sure to activate the virtual environment. All right, here we go. Cool. So, and our application is inside here. This is our video stats stack. And just a quick explanation, in CDK, in the AWS Cloud Development Kit, you can program your infrastructure using actual programming code, using a programming language like Java or C# or TypeScript, JavaScript, Go, or Python, like I do in this case. And you can see here what I'm doing here. I'm creating a bucket. That's the bucket that we talked about. I'm creating some pieces that are necessary to be able to monitor the bucket, so to be able to react to it whenever something is being uploaded. And that's this trail over here, and the put object event rule that we have down here. That is an event rule that triggers whenever a new object is put into the bucket. And then over here, we have the state machine. And this is the important part. The state machine is where the actual processing happens. Let's have a look at that real quick because we already deployed it into AWS. The state machine is down here. This one, the process new file, this one. It's called process new file, and you can see it here with a random ID in the back. And I'll just go ahead and render this graph. This is our state machine. And all it does, let's make it a little bit bigger. All it does, basically, it starts whenever it's being triggered. Then we have dispatch file. And dispatch file just is a choice state that decides based on the actual file what to do with it. And if it is a YouTube file, a YouTube statistics file, it will go into here and process the YouTube file. If it's not a YouTube file, it just go down here and end the process. So we're not doing anything. If it's a YouTube file, we'll go through this. And this process YouTube file, let me look it up real quick. This process YouTube file, that's the dispatch file with its choices. And let me, here we go. This is the one I'm looking for. The process YouTube file step, this one. Let's format it a bit. Here we go. So, this is what I'm looking for. Got a typo here. So the process YouTube file step or task, it's a task and it invokes a Lambda function. So what it does whenever it goes into, let me do that again. Whenever it goes into here, it invokes a Lambda function. And this Lambda function, I'm going to open that up real quick. Don't want to save this. This Lambda function is in here. Oh, I'm in the wrong file. I need to go here. Is in here. And this is our Lambda function. This just takes the event. The event contains the data, so the information of the bucket and the actual file. And what it does right now is really just extract all the lines from that file, except the two header lines. It removes these two. Line number 1 with the headers, line number 2 with the totals information. It removes these two and then sends all the other lines downstream to the next process. And what we want to do in here, instead of sending it further, we want to store all the data. And let's just run a test of this Lambda function to see what it produces. And I'm going to run this locally. So I'm going to deploy the Lambda function locally in a Docker container just to see what it does. And this takes 1 or 2 seconds, or maybe a little bit more. And for everybody who's just joined, welcome to the stream. My name is Dennis. I'm a developer advocate. I work at Amazon Web Services. And today we're just walking through the building of an application on AWS using serverless tools like Lambda functions, step function state machines like Dynamodb tables, event triggers, S3 buckets, and so forth. So what this is doing right now, it's building a Docker image with the actual Lambda function that we have here. And it's going to deploy the Docker image locally and invoke it so that we can test our Lambda function locally without having to upload it to AWS all the time. So now it's mounting the directory. This just takes a second. Grab a drink real quick. And as I said, if you have any questions, please let me know. I'll try to answer as much as I can. This is still taking a few seconds. Oh, all right. Here we go. So it's starting the SAM application locally. SAM stands for Serverless Application Model. Here we go. All right. And that was it. This is the data that's being output. As you can see, this BNH4 something, install the AWS CLI on macOS. That is exactly what we have up here. So the Lambda function took each of these lines and put them, extracted them, and put them in an array. This array did that down here for every line in the body of the file. Iterate over the line, append the content of the line to our items, remove the first two items, so pick everything from item number 3, and then return the items. That's everything our Lambda function does, and then what we want to do today is really, instead of returning it, is writing it into a DynamoDB table. To be able to do that, we need to create the DynamoDB table. Now let's have a look at that. I'll go back to our stack. And what I'm going to do here really is just start typing table is DynamoDB something. What I want to do really is I want to use the CDK to create a CDK construct to create the DynamoDB table. And for that, I'm going to look it up in the documentation. So AWS CDK Python reference. Let's have a look. Here we go. So that's the reference, and I'm going down to look for DynamoDB. Here we go. AWS CDK, AWS DynamoDB. Let's have a look at the package overview. So everything we need to create a DynamoDB table is this piece of code. So we use the API or the SDK, say we want a table with some arguments, and we need a partition key. We cannot create a table without a partition key, and we can use an attribute with a name and with a type as partition key. So let's do that real quick. We use DynamoDB table from the AWS CDK AWS DynamoDB package. Let's go back to our Cloud9 environment. And up here, let's use from AWS CDK. We got that from AWS DynamoDB. AWS DynamoDB DB as Dynamo. And to be able to use that, we have to import it. I'll do that in our requirements. So I'll say AWS CDK, AWS DynamoDB, and just down here, do a quick, I don't need that anymore. Yeah. Pull that down here. Just down here, do a quick pip install -r requirements text. So this will install all the dependencies that we have in the requirements. Hey, Sebel, first time seeing CDK in another language than TypeScript. Yes. Actually, I'm experimenting with it. Here you go. Actually, I am experimenting with it. I never used the CDK with Python before. So this series really is an experiment for me in using that as well. So let me see. So we've installed everything. We've installed all the requirements. So what we do have here really is we downloaded the dependencies, so we can say table is dynamodb.table. And just like every construct in CDK, we need to send it self, so the surrounding stack, because just real quick, if we look at, I'll change the color again real quick because blue is a little bit dark. All right, here we go. So if we look at CDK, or the cloud development kit, in CDK, we have, I'll do it the other way. Let's see. We have an app. That's what we're building. And inside of the app, you can have one or multiple stacks. In our case, it's just one. And inside of the stack, we're using constructs. And our Lambda functions, our Dynamodb table, our S3 buckets, all of these are constructs. And they exist inside of a stack, and the stack exists inside of the app. So for CDK to know what exists where, we always handed the so-called context. So the stack, this is the stack, and each of our constructs that we're using needs a reference to the stack, and this is the context, and we'll just give it self, referring to the stack, and we'll give it an ID. In this case, let's just call it YouTube data, YouTube statistics, or let's call it video statistics. I might not just want to store YouTube videos, video stats. I might want to store stats. So let's call it, just call it statistics. And as we saw in the documentation, what we need here is at least a partition key. So the partition key, I'll just copy that. Partition key is an of type attribute with the name ID, and the type could be string, but it could also be, let's have a look at the Dynamodb table. Here we go. The type, where are we? Encryption. You can define all kinds of things, but we really just need the partition key for a start. Where are we? Encryption key. Where's the partition key? Where is the partition key? I can't find it. Let me see. Here we go. Here it is. And that's of type attribute. And the attribute, again, can have an attribute type. And this could be binary, number, or string. So we're going to use string. And I'm not going to call it ID. I'm just going to call it PK for partition key. And this will create a Dynamodb table with a partition key of type string called PK. In our case, I also want to create a sort key and not just a partition key. And to do that, let's have a look at the documentation. Let's go back. That's the partition key. And this is the sort key. So we can also add a sort key with an optional attribute. Let's see. What if I say sort key is, again, Dynamo, and I didn't call it DynamoDB, I just called it Dynamo up here. That's where I imported. I'll call it DynamoDB. Let's make it clean and readable. So DynamoDB up here, dot attribute, and this should have the name SK for sort key, and the type should also be a string. There we go. So let's see if this compiles by simply saying cdk diff. Yeah, as you can see down here, it is actually creating a table called statistics with a random number back here. So let's do that. Let's do that. Actually deploy this and have a look at the table in the AWS Management Console. Let's say cdk deploy. And this will compile our application, or rather it's Python, so it won't compile it. But from our application, it will then synthesize a CloudFormation template. It will deploy this CloudFormation template into our existing environment. And because we already deployed some things like the S3 bucket and the Lambda function and the step function state machine, all it needs to deploy now is the new DynamoDB table that we've just created. And Sebel and everybody else, if you're wondering, up here, this is not what the CDK in Python looks like, because what I did here is just create separate classes where I to just refactor the creation of the actual resources into those classes to keep the stack definition clean. And I'm going to do the same thing with the table once it works, just to make sure that it all stays clean and isn't too cluttered. So as you can see, we've got a create in progress down here, and it's done. It's already done. Let's go here. Let's have a look at DynamoDB. And inside of DynamoDB, we have tables. We've got one table, and now it's called the Video Stats Stack, Statistics. And here we go. And it has a partition key with the name PK of type string and a sort key with the name SK of type string. We've got 5 RCUs and 5 WCUs, so 5 read capacity units and 5 write capacity units deployed. And I'll get into what that is later today when it comes to actually writing and thinking about cost. So here we go. We've got our table. Let's go into the table. Let's have a look at the items. There is nothing in there right now because we just created the table. So what we're going to do right here is really refactor this into its own class real quick to then use it. And what I'm going to do for that really is I'll go down here, say class. Let's call it statistics table. And inside of the class, I have a static method. And I'm just going to call that create. Using the same pattern I have up here, simply say create. This will take the scope, and it will take an ID. And that's it. And in here, we do this. We create a table with the scope and the ID. And then we're going to return the table. And since, yeah, we're going to return the table. Let's just take this and add it to a new file in here. So let's create a new file. We'll call it statistics table.py. Open it, add this, and we also need to add the reference to the dependency up here. We need to import the dependency, but we only need to import DynamoDB. And over here, we have to add from file processing. So this is our folder, file processing, and we called it statistics table. Import, and let's just call it statistics table. And now we can simply say down here, table equals statistics table create, give it the scope, and give it an ID, and we called it statistics table, right? So we've got that down here. And now if we say cdk diff, there shouldn't be a difference because we just refactored without changing functionality. That's what I hope. So it does destroy the table, and it creates a new one because we renamed it here. We renamed it to statistics table. Let's see. Did I just name it statistics before that? Let's see. Here we go. No differences. I changed the name and I shouldn't do that. So now there's no differences. We don't need to deploy anything. However, I would like to just commit this to Git. So let's say git add all, git commit -m for message, add statistics table. And statistics table. Yeah, here we go. And that's it. Now we've got the table, and our Lambda function can actually write into the table. Now let's see. Let's have a look. That's the table. Inside of our state machine, we have our Lambda function. And the Lambda function, again, where is it? We don't need this. The Lambda function is here. So this function should be able to write into the table. How does it do that? By simply saying Dynamodb put item. So it calls the put item API of Dynamodb. To be able to do that, we need a Dynamodb client. Let's call it DDB equals. So we assign Bodo3, which is the Python SDK. Let's say resource. We create a new resource, Dynamodb. And with that, we're now able to write for each item, also for item in items, write item to Dynamodb table. That's what we want to do. So let's have a look at the documentation. I'll open a new tab, AWS Bodo3 Dynamodb. Here's the documentation. And inside of the documentation, we can see we've got the service resource. This is what we're using. And now we can go and look for the table. And we create the resource to work with it just by giving it the table name. So all we need to do is really table Dynamodb table name. Here we go. And this is going to be interesting. So our table name. Now, where do we get the table name from? Because if you remember, CDK gives it a long name with some random parts. If we look at Dynamodb again, this table's name actually is video stat stack statistics 0645-15 something. So that's the table name. And while we are writing this function, we don't really know what the table name will be. So imagine we deploy this to a different account, or we destroy it and redeploy it. The DynamoDB table is going to have a new name, and we can't hard code that in here. And to do that, what we can do is introduce an environment variable. Let's say up here, we say table name equals, and now in Python, we can say OS environment. Is it environment or environment? I'm not entirely sure. Let's see. Python OS and environ. Here we go. We've got the OS environ object. Here from OS. Where are we? Yeah, here we go. Environ, and then the name. OS environment, and let's say we'll call it table name. So this way, we're getting the table name from the environment variable. And we have to put it there to be able to use it. How do we put the table name, the actual table name, into the environment of this Lambda function? To do that, let's go to the Lambda, to the actual definition of the resource, which is here. As you can see, this is where we create a Lambda function. We have the function, Lambda function with a scope and an ID and a runtime and so forth. And what we can do now really is say function dot, and let's go to the documentation. We've got AWS, where is it? Lambda function. Where's the function? Down here. Inside of the function, we can now say function here's the add environment. And that's what we're looking for. We have the method add environment, and it takes a key and a value. The key is the environment variable, it's the name, and the value, well, it's its value. So let's go ahead and take this function add environment, and let's call it table name. And now we need to add the actual table name. Let's use a variable table name. Oh, let's just use a table. Yeah, and the table name should be table name is table, and in the CDK table, let's go back. In the CDK table, we have an attribute down here somewhere, all the way down. We've got the table name. So we can say, give us the table name of our table. To get our table, we need to inject it. And we have to do that here. So we're giving the state machine not only, so the Lambda function, yeah. So the Lambda function gets the table. The Lambda function is part of the state machine. So we have to add the table to the state machine. We need to put it up here. We go to the state machine. This is the state machine, which takes a table. And then it sends the table to the Lambda function, injects it into the Lambda function, and the Lambda function can use it. Now let's see if that works. I'm just going to use that here like this. So we're adding the table name to the function's environment. I'm going to do a CDK diff real quick. Here we go. So it's doing a few things. Starting here, it's doing a few things. Specifically, it's going to change the function, the Lambda function, and it's going to add the environment variable pointing to our statistics table. And this is something in CDK, it's called late binding, because we don't know the table name at runtime. We only know it once it has been deployed. And so it will make sure to add the actual table name once the table has been deployed. So let's go to a Lambda real quick and have a look at our function. This is the function. And in the function configuration, you can see that it doesn't have, here we go. Here's the environment variables. It doesn't have any environment variables right now. And once I say CDK deploy, it should change. So it synthesized a new template. It creates the change set. So it infers the difference between the environment as it was before and as it should be. Now it's updating the stack. And once it's done updating the stack, as part of updating the stack, it will change the Lambda function's configuration, adding the table name. Here we've got an update in progress. It's updating the Lambda function. And once that's done, we should be able to see the environment variable inside of our function configuration. It's almost done. Here we go. So now let's reload this page and have a look at the configuration. As you can see, we now have the table name with the actual table name. And with that, our function can use it. Now we can say OS environment, so we might need to import the OS. And right now, I'm just going to test that locally. No, I don't need to test that locally. I'll just deploy it as it is. This won't run because we don't have an actual code. So let's see. For now, let's do that. Let's do that. Let's write the item to the DynamoDB table. So we're going to say DynamoDB.put item. Have a look at the Bodo documentation. So we've got the table and the table, not DynamoDB. We need to do we need to use table. So this one, table put item. And right here we go. We've got put item, and put item takes an item. And I think that's really all it needs. The item is required. Everything else is optional. So we'll use the item. And let me look real quick. Yeah, so we say put item, and then we send it an item. Put item. And this is our item. And the item, again, should have the what do we have? We have the PK. No, we're up here. We have the, let me think. The documentation isn't very good, so let me look it up here. Bodo 3 DynamoDB put item. Here we go. Yeah, we have to put we need the table name. No, we also already have the table name. And then we simply say, all right, this is using the client, but I want to use the resource. This is using the resource. So right here, this is one. We say put item, and then we just give it the item, the ID. Okay. So simply say, let me see real quick. Simply say PK, that's our primary key. Let's call it PK for now. SK. And data. Let's call that data. Yeah, let's do that. And right here, we'll add the data, whatever that is. So, okay. So that's how we call the DynamoDB API. Now, what exactly do we want to write? So for that, let's have a look at the actual data. So we do have a video ID, and we have some additional data. And let's think a little bit about how to model the table. So this is our DynamoDB table. And let's say we have our PK, we have our sort key, and we have the data. So PK, partition key, sort key, data. What do we want to store? The partition key should be the video ID. And for now, I think the sort key can just be video. And the data is the actual content. So let's see. Where were we? Here we go. So the sort key should just be data, video. I said video. I'll call it video statistics. Or I'll call it YouTube. Video statistics. The PK should be the actual ID. I don't need that. The PK should be the ID. So for item in items, PK is get video ID from item. And the data should just be, I'll just store the item as it is. Okay. Now let's have a look at what the item looks like. We had that before. No, I closed it. But we can have a look at a step function execution up here. Let's go to step functions because we did that before. This is our state machine. We've got this execution from a week ago. Let's just have a look at the output of this one. And this is what the actual data looks like. So we have this. Okay, that's a string. That's a string. So we need to extract this part from the string. How can we do that? By splitting the string at the comma and taking the first item. So let me just take this real quick and add it here. That's what it looks like. And we want this. So Python split string. Okay, simply say string split. Okay, let's try that. Let me just fire up a REPL real quick. Python 3. Let's say item is, and now I'm gonna add this. Now let's say item dot split. We get, okay, that's exactly what we need. So if I say item split and I take the first item, I get that. So let's just take that. PK is this one. Okay. And I'll store the whole item, including everything, just as a string in the data attribute. So that's the Lambda function, but this won't work because the Lambda function right now doesn't have permission to, let's go back real quick, it doesn't have permission to write to the Dynamodb table. So if we go to go back to our Lambda function and look at the permissions, here we go. It is only allowed to write to CloudWatch and read from S3. It's not allowed to read from the table. So that's something that we need to do. We need to, right here, we also need to give the Lambda function permission to write to the table. And the way we do that is in here, we simply say table dot grant. Now let's see, table grant read data, read write data. We want to do grant read write data on the table. And we want to grant that to the function. And that's really all we need to make sure that the function gets all the permissions necessary to read from and write to the table. Yeah, just gonna try that. Let's see, and do a CDK diff. Okay, cool. So that went through. It is changing permissions, and that's why we need to go through this and have a look. So it's giving batch get, batch write, condition check, delete, get, put, query, scan permissions. It's giving these permissions to the service role of the Lambda function. And the resource is the statistics table. So that's what we want to do. These are the new permissions. This is the new permissions document. And it's going to deploy the new function code. Now let's try that. Let's say Let's say CDK deploy. To deploy the changes, and then we'll have a look at the Lambda function permissions configuration to see if it's, yeah, we want to deploy the permission changes. And then let's look at the Lambda function configuration to see the new permissions. So this takes a second. It has to redeploy the function with the new code, the code that we changed, and the new policy, the new permissions. Here we go. Here we can see the policy is being deployed or updated. Now the Lambda function is being updated. And once that's done, we should be able to, we should be able to reload the function. Have a look at the configuration. And as we can see here, we've also have DynamoDB permissions. Now I'm not entirely sure if everything works because I didn't test the actual function, but let's do that real quick by simply uploading the file to S3. Let me reload this real quick just to make sure and that's what I thought. I have to create a new session. Here we go. Let's open Cloud9 again. Open the IDE. Here we go. So and it's loading the resources. It's connecting to Frankfurt. In Frankfurt, we've got the S3 bucket. And this is our video stat stack data bucket. Let's look in here. I'm going to just delete this file. And now I'm going to upload it again. This one. Let's upload the file. So it has been uploaded. And now let's have a look if we have a step functions execution. Because as I said before, just real quick, as I said before, whenever we have a new file, this should trigger the processing of the file, including the Lambda function. And now the Lambda function should store the data into a DynamoDB table. Let's see if that worked. Let's go to step functions. Here's our step functions state machine. Now let's have a look at the executions. So that failed. Well, that was to be expected. It never works the very first time. Let's have a look what happened. Let's go in there and see where it failed. So this one failed. We have an exception. So name DynamoDB is not defined. We've got a name error because DynamoDB is not defined. Okay, let's have a look. Where's our Lambda function? Here we go. So where was it? Here. So in line 22. So this is line 22. Yeah, right. We called it DDB. We called it DDB. And I'll take that and pull it all the way up. There we go. So we've got our table. Yeah, this is our table resource that we're working with. And we are using it down here. Okay, now let's deploy that again. CDK deploy. And while this is deploying, we can delete this. So the update is in progress. It now will upload what's happening in the background right now is CDK creates a zip file from our Lambda function, uploads the zip file to a staging bucket in AWS, and from the staging bucket, it deploys the new function code, the changed function code into the Lambda service. Now the update is running. And this is the thing, the publishing here, that's where it refers to the package that's being uploaded to the staging area. All right, so let's see, we'll go back to our executions. This one failed. Let's do that again. Let's try it again. So let's delete that. We already did that. Let's upload the file again. Okay, and have a look here if we have a new execution. So this one is the execution E0F. If I reload the page, we have a new execution, CFB, which failed again. Let's have a look. And it failed here again. Let's have a look. All right. Oh, okay. So, and this is interesting. The task timed out after 3 seconds. So the Lambda function ran for 3 seconds. And after those 3 seconds, apparently it wasn't done yet. So it timed out. What we need to do is to increase the runtime of our Lambda function. Once we've done that, I would like to have a look at why does it run so long? And does it really need to run so long? Because the longer it runs, the more cost the cost increases and everything. I'd just like to see if we can shorten that. But for now, to make it work, I will have to increase the maximum runtime of the Lambda function first. And we will do that in the function itself. Let's have a look at the documentation. Here's Lambda. Our Lambda function takes another argument called, let's see, I have to look it up. Where is it? Timeout. Here it is. We've got the timeout, which takes the duration. And the duration is, where do we have it? I can't see it. Oh, okay. Duration, hours. All right. So it takes from core, it takes this duration. So we do have a timeout. And now we need core, or rather CDK, and that is this here. So timeout is core duration And now let's see, what do we have? We have hours. We probably also have days, hours, millis, minutes, seconds. Let's say we want it to take at most 1 minute. So we'll take minutes. All right, let's take seconds. Let's go with seconds because I want to reduce it. I don't want to keep it at that. So I'll say, duration, seconds, 60. So, all right, let's do another CDK diff. Let's see what happens, if that works. All right, name core is not defined. From AWS CDK import core as CD. Oh, I imported it as CDK. I didn't import. Here we go. So I'll call it CDK. All right, let's do that again. Okay, so cool. We have a timeout set to 60 seconds. I'm going to deploy that. While it's deploying, welcome everyone. If you're new, if you have joined, we're in the middle of building an application using serverless technologies on AWS, like Lambda functions, step functions, state machines, Dynamodb, S3, and so forth. And I'm deploying everything using the AWS CDK, the Cloud Development Kit, using Python as a language. And we're just walking through it. This is nothing that I have prepared. We are really learning together as we go. I'm just deploying a new version of the stack where I've increased the timeout duration of the Lambda function because apparently storing the data into Dynamodb took more than 3 seconds, which is the default timeout of a Lambda function. So it's updating the function now. And while that is running, let me delete that file again real quick, the test file. And here we go. And now let me upload it again. Here we go. Let me upload the file again. And now let's have a look at our step functions execution. It's not there yet. Okay, it's still running. As you can see, it takes a little bit longer. Gonna reload that. And this time it succeeded. So let's have a look. So it went through. We have no exception. And if we look into Dynamodb now, into our table, we should have items. Here's the table. And let's view the items. And here we go. We have the items stored the way that I wanted. We have the ID, the video ID as a PK, as a partition key. We've just got YouTube video statistics as sort key. We might change that later. And we have the actual data in here. Let's have a look at one item. Yeah, we have the actual data here with, again, the ID, the title, a date, and some numbers. So that's exactly what we wanted to do. We wanted to store the statistics of all our videos, or all my videos on YouTube, into a Dynamodb table. Now, that function ran for 5 seconds, almost 5 seconds. Let's have a look at this one, the details of the Lambda execution. The details of the Lambda execution in the CloudWatch logs should show us how long it really ran. And that's right here. This is the one. And it ran for 3.8 seconds. And the build duration is also 3.8 seconds. And this is very long, given the fact that we're just writing a number of entries into a table. This is quite long. And now let's have a look at why does it take this long. Let's have a look at DynamoDB. Let's have a look at the table and the metrics of the table. So here's the write usage. And I could imagine, we can't see it yet, maybe because it will take some more time to show up in the logs, but I could imagine that we ran into a throttle because we tried to write too much into DynamoDB at a time, and we haven't provisioned enough bandwidth. And this is one thing that's really important with DynamoDB. You pay based on the amount of bandwidth that you provision. And the bandwidth is measured in write capacity units and read capacity units. And let's have a look. DynamoDB, WCU, and RCU. And let's have a look. So here we go. A read capacity unit. So let's go through this real quick. Let's make it larger. So here we go. A read capacity unit. Each API call to read data from your table is a read request. It's the same with write capacity units. And right now we're thinking about write capacity units. Each API call to write data to your table is a write request. So we have in our file, we have 112 entries. It's 114 minus the first two. So it's 112 entries. So we are sending 112 write requests to DynamoDB. Let's go back to the documentation. So each API call is a write request. We have 112 of those. So let me see. Where's my pen? Oh, got it the wrong way. So that's 112 write requests. For items up to 1 kilobyte in size, one WCU can perform one standard write request per second. So our items are, let's have a look again. They're pretty small, so our items are up to 1 kilobyte in size. So none of those is more than 1 kilobyte. That means we still have one WCU, one write capacity unit, as one standard write request per second. So for 112 items, if we want to store those within a second, we would need 112 WCUs because we have 112 requests writing data of up to 1 kilobyte in size. So that's 112. The default, and now let's go back to the table. The default capacity is, let me see. Let's look here. DynamoDB default WCU. Here we go. In provisioned mode, let's see if we've got it down here. Nah, it's not here, but I'm sure we can find it over here somewhere. So the capacity mode is provisioned. Right, we've got it here. Just have to click on it. So we have 5 RCUs and 5 WCOs. So the thing is, we want to write 112 items, but we have only 5 write capacity units provisioned. So we run into a capacity issue. We could edit the capacity and add, let's say, 112, but that would make it quite expensive. The estimated cost right now with the setting that I have is 3.54. If let's say 1112, now we're at $66 per month for the provisioned write capacity units, and that doesn't make any sense at all. That's way too expensive. I want to leave it at 5. I might even want to reduce it to maybe just 1 to make it even less expensive. So I'll leave it at 5 for now. I'm not going to change it. What I'm going to do is think about a way to write without needing that many WCUs. Now let's have a look at the monitoring real quick. Because once we exceed our provisioned capacity, it will be throttled. And you can see we've got a put latency of a lot. So we probably had some throttling in place, because DynamoDB, once you exceed the capacity, it just throttles the requests so that it spreads out the requests over time, which again means the Lambda function runs longer, which again means the Lambda function runtime is longer and it costs more. But there's one thing you can do with DynamoDB, because each of those is way less than 1 kilobyte, and we can actually combine them into single calls, meaning we can batch write them to DynamoDB. We can just take as many as we need, up to 1 kilobyte, batch write them, take the next kilobyte, batch write them, and so forth. So in this case, we make sure to really use the whole capacity that's available to us. So we're not just, we don't have to do 112 write API calls to DynamoDB, but instead, how large is that? What's WC? Help. WC, I want the number of bytes. Okay, WC-B, and that's data. Oh, okay. Oh, C, it's not B, it's C for characters. Let's count the characters. So it has 11,710 characters, and that's 11.7 kilobytes roundabout. Not exactly, but it's 11.7 kilobytes. So it should be able to only use 11 or 12 read requests instead of 112 by using the batch write. And to do that, what we're going to do is go back here. Instead of saying table put item, let's go here and have a look at the batch writer. We create a batch writer, and into that batch writer, we can then put items, and this SDK will, the batch writer will take care of writing as many as it can to max out the capacity. So what we will do here is, let's say for items, we don't want the item in items. What we will do is with, with table batch writer as batch, for item in items, say for item in items batch put item. And now we're just going to do what we did down here. Take the item, remove this. So we used the DynamoDB batch writer and put the items into the batch writer, and the SDK will just make sure to flush the batch writer whenever it's full to then store the data. Now let's have a look. Let's deploy this. And I'm going to go to DynamoDB and just have a look at the items. And I'm just going to delete all of them. So that we have a fresh slate, an empty slate. I'm going to delete this. So here we go. So it's empty. The DynamoDB table is empty. Let's have a look at the table again. Here we go. So okay, it's deploying the stack. And let's see. So our last execution of the Lambda function needed 3.8 seconds. Now let's see if we win something. It has been deployed. Now let's go ahead and upload the file again and see if we have any significant changes. All right, I need to reload, just, yeah. Refresh the session. It's connecting, Frankfurt S3, so I'm gonna re-upload the file. Video stats, data, YouTube, upload. So the upload has been done. Let's have a look at the execution. Oh, it has failed this time. So I might have an error in my, so it failed with an exception. Name PK is not defined. Okay, so I broke something. Yeah, right. Let's see, I'll copy that. Yeah, I need the PK. I can't forget the PK. This is here. And I'll just use that in here. Can remove this. Let's see. So it's we use the item, split it by the comma, take the first. Okay. All right. So let's say CDK deploy again. It's creating the CloudFormation change set again. It's updating the stack. And the nice thing with using the CDK and infrastructure as code, it is so reproducible. So every time I do this, it does the exact same thing. And it's much better than having to click through the console and not being sure what I did and what I maybe missed. Of course, there's still trial and error when I deploy into a test environment. However, once all that is done, it's done. And I can deploy it into multiple accounts even. I could deploy it into a test account. I could deploy it into a live or a staging or a live account. I could even give it to somebody else. I could upload it to GitHub, and somebody else could use it exactly as it is. So here we go. We got that. And let's have a look. I'm going to upload the file again. Here we go. Now it's been uploaded. Let's have a look at our executions. It's running. Oh, it just tells me my mouse is empty. Just give me just 1 second. I'll be right back. I need to plug in my mouse because it's emptying. Here we go. That's when you go wireless. It's very convenient, but every now and then it's out of power. So, all right, here we go. Okay, cool. So it has succeeded this time. So let's have a look. Here we go. And the execution time was, in this case, $740 milliseconds. So as you can see, we have cut our execution time. Well, that's 20%, down to 20%. We have cut it by 80%. We have reduced the execution time by 80% only by using the batch writer instead of putting every item into DynamoDB. And that's a lot of progress, because that makes the Lambda function much less. It runs faster and it's less expensive, or it costs less. But at the same time, we're doing the same thing. So that was a little bit of optimization, reducing the runtime by 80%, simply by batching our writes instead of just writing every single item. But now there's one more thing that we can do, because the Lambda function still runs, as we just saw, still runs 740 milliseconds. Now, is there a way to reduce even that? And I would like you to think about it for just 1 second, for just a minute or two, and I'll have a quick break, and you can have a quick break if you want to, for just 2 minutes, and I will put it on the screen. Let me see. I'll create a banner. Can you think of a way to reduce the runtime of our Lambda function even further? If you want, have an idea, please put it in the chat. I will be right back. Here we go. Add banner, show. So I'll remove my video real quick. I will be back in a second. All right, I'm back. So did you have a chance to think about it? I had. So what we're trying to do right now, let me go back to the drawing board real quick. So we have right now we have a Lambda function. I can't paint. So that's our Lambda function. And what does it do? First, it gets S3, gets file from S3. Second, it extracts data from file. Third, it batch writes data to Dynamodb. And this all takes, with the batch write, 700 something, let's say 800. Make that clean. That takes around about 800 milliseconds. Now, there's one thing that we can do to reduce the execution time of the Lambda function by removing this step from the Lambda function and doing it outside of the function. Because the very nice thing here is, if you remember, the Lambda function is part of a step function. That's not a, oh, come on. Is part of a step function state machine. Oh, come on. The Lambda function is part of a step function state machine. And one thing that you can do inside of step function is directly use the API for many services, including Dynamodb. So what if we have the Lambda function do this and have the state machine, so that's the Lambda function, and have the state machine take care of writing the data into Dynamodb? Because in that case, what we can do is we've got our Lambda function, and the Lambda function sends all the items to step functions, which then can write all the data in parallel. However, the Lambda function is done, so it doesn't need to run anymore. And the state machine takes care of all the write, because for the state machine, it doesn't matter how long it runs. A state machine, a step function state machine, isn't paid by the hour. So it does not matter how long it runs. In this case, you can simply say, I've got my Lambda function to extract the data from the file, and then just send the extracted data downstream. The Lambda function can be done, so it can shut down, doesn't need to cost anything. And then the state machine can take care of the rest, just to make sure that everything gets written into Dynamodb. And the way we do that is the following. Let's have a look at, let's close that and this. The way we can do that is by, and I hope my microphone is on. Yeah, it looks like it is. The way we can do that is, let's have a look at the state machine. Here we go. And I'm going to use the editor just to show how that works. Let's go to the workflow studio. Right, here's my workflow. And what I can do now is, let's search for Dynamodb. As you can see, we've got a put item task. We don't even need a Lambda function to put an item into Dynamodb. We can just put it there. And we've got a few more. We've got get item, update item, delete, batch execute statement, batch get item. And we also have the batch write item task over here. Let's see. So, but let's go with put item first. Let's go with put item first, this one. Right here. So what we can do is from the Lambda function, just send the items downstream and have the step function state machine take care of putting the item. It doesn't work this way. What we need really is a parallel process. Or no, we need a map. We need a map which does a for each. And in there, we need Dynamodb item. So this is what we want to do. We want to take every item that we get from the Lambda function, and for each of those items, we want to put it to Dynamodb. And the thing is, even if we're using a simple put item here, and we're not maxing out the capacity, it doesn't really matter because the state machine can then just spread it out until it's done. If it doesn't need to be done within a second, it can run 3 seconds or 4 seconds, which may still be fine, but it doesn't cost you anything in addition because the Lambda function doesn't have to run longer. So let's see. We need a map state, and then we need to do the Dynamodb put item. I'm going to remove that for now because I don't want to change the state here. I want to change it in the CDK. So let's have a look. This is our Lambda function. And I'm just going to commit that real quick. I'm just going to simplify it a little bit. Use that here. And we can simplify that. Let's simplify this just real quick, just to make sure that it. So we can even say, we can put that in here. No, we don't want to do that in here. So what we want to do is for item, because we want to extract the data from the item so that then the state machine can just use it. So for item in items, let me see. Let's do that. For a line in file, let's say item is line decode. Item, let's assign line decode to item. And then we can say items.add. And now let's add the following. Let's add exactly what we want to write. PK. Add exactly what we want to write. The PK, the item. So, yeah. Yeah, that's exactly what we want to do. So, and then we can return the items. Let's just comment this real quick. Yeah, and then we're going to return the items. Now let's have a look. Let's test this file. This thing. Let's test it locally. And to be able to test it locally, I need to run it locally. And to be able to run it locally, I need to add the environment variable to the run configuration. Let's have a look. Edit launch configurations. This is the one. And let me look that up here real quick. Because Yeah, so we've got the runtime. We've got the environment variables down here. And in here, I'm just going to add table name and use the actual table name, which is this one. All right, so just to make sure that everything works when I run it locally, so we have the table name, but in fact, we don't need the table name because we are going to, we're not writing into DynamoDB anymore. So we can remove this. We can change the launch configuration, remove that. I don't need that. Don't need DynamoDB, don't need this. All we want to do is that, and we've got the output. So let's try and run this. Just test it locally. And now it built a new container image. And once that's done, it's going to deploy the container image and invoke it using our test event, pointing at, here's the test event, pointing at our file. Yep. And then we should get a list of objects. Here we go. All right, so we've got an error, syntax error, invalid syntax. Line 20, runtime request ID, stack trace. Okay, line 20. Yeah, that doesn't work. That doesn't work. All right, let's run it again. And it takes a little bit of time every time because it has to create a new container image and it has to deploy the container and run the container locally with the Lambda runtime environment. However, that's still simpler than deploying it into AWS every time and having to go through the whole process, because here we can just test it with a test payload. All right, we still have a syntax error. What's the issue here? Is it append item? Let me see, Python append to array. That's what I'm doing. I'm using append. Oh, yeah, right. I'm not using it as a function call. Sure. And that's the thing with coding. I mean, if you do any type of coding, you know that these are the things that get you all the time, where you, hey, next up, this probably gets you all the time whenever you write something that you just miss a parenthesis or a bracket or a comma. Hey there, looks like I got a raid on Twitch. Thanks for joining. We're in the middle of refactoring our function where we write data from a CSV into DynamoDB. VSC, was ist VSC? The thing is, thanks for joining, Hämorrhoidenprofi. This is an English language stream. So, but I don't, no, I don't, I'm sorry. Ich spreche normalerweise Deutsch, but I'm not speaking German on this stream because this stream is for an international audience and we have viewers from all over the place. I'm not using VSC. All right. No, it's not Visual Studio Code. What I'm using is Cloud9, which is an IDE inside of AWS. All right. So does it run? Did it run? I'm not entirely sure. It's still deploying the container. And it takes just another second. Oh, thanks for the note. It shouldn't be listed as German. I didn't change the default settings, so it isn't German. I'm sorry. It's an English language stream, and it wouldn't make any sense to speak German because many of my viewers are from India, the United States, and all over the place. So, however, thanks for joining. If you speak English, if you understand English, thanks for joining. We are. I assume that you're done with your stream. Thanks for the raid. What I'm doing here is I'm building an application using AWS, Amazon Web Services. My name is Dennis. I'm based out of Hamburg, and I'm a developer advocate. I work at Amazon Web Services, and I use this stream to basically walk through a few things, building something, my thought process and everything. Christoph, tut mir sehr leid, der Stream ist leider, ich habe ihn leider offenbar als Deutsch markiert, das war aber mein Fehler. Der Stream ist Englisch, weil ich viele Zuschauer aus Indien, USA und so weiter und so fort habe. Deswegen macht es keinen Sinn, wenn ich Deutsch spreche. Sorry. So here we go. It's doing something. It's doing something. All right, so I'll try to redeploy. Yeah, I'll try to redeploy locally and run it again. And what I have here, this is a Python. This is a piece of Python code for a Lambda function that's supposed to be executed. So, and Christoph, I'm really sorry, it's not a German stream, even though I mismarked it as German. Yeah, good, thanks. That might be the thing to do here. All right, so it's deploying, starting the SAM application locally. It's waiting for it to start, and okay, we've got a runtime exception. Let's see. Get item, raise key. Why is it having issues with the table name? Oh, because I got it up here. Damn. Don't want to use that. Now let's run it again. And that's exactly the thing. You always miss something. So we don't need the environment variable because we're not using DynamoDB anymore in this function. So it's running. And while it's running, let me just clean up a bit. We don't need that. We don't need this anymore. Here we go. And now it should just extract the data from the file. What I'm doing here for everybody who just joined, I'm extracting data from a CSV. I've got a CSV with all my viewing statistics from YouTube. And what I want to do is whenever I upload a new statistics file, I want to automatically trigger a process that extracts the important information from that statistics file and stores it in a table in DynamoDB. And right now we're working on a Lambda function, which is a function inside of AWS that just executes on demand, that does all that stuff. So yeah, I'm being trolled, I guess. I'm being trolled. You can feel free to report. So, all right, here we got it. And that's what I was looking for. Down here, we've got an array of objects having the PK, the SK, and the data. So once I deploy this, let's say CDK deploy. Once I deploy this, I should be able to do that before I'm done with the stream, because we're almost 2 hours in by now. Yeah, this stream used to be German right in the beginning, but it turned out that I have so many international visitors that I figured English would be better, because it's, well, generally a little more inclusive towards people who are not from Germany. I hope that works out for you. So it's updating the video stat stack. It's updating the Lambda function, deploying the new code. All right, so it's been deployed, and now I should be able to, I'll just reload the page to refresh the session. Now I should be able to upload the file again. And let's go back here. We've got our execution. The last one was the 680B. So once I go here, S3, and upload the file again, data, YouTube, upload. Now let's have a look at the execution. We've got a new execution, this one. Let's have a look. Here we go. So it went through the state machine, and here's the step output. This is what we're looking for. So we do have a payload, and this is exactly what we need. This is exactly, we've got objects, and we can then use these objects in a map task that then just iterates through all the objects and does the API calls to store them into Dynamodb. And for today, I'm just going to do that manually and not part of our infrastructure as code, to see if it works. Let's go to the Workflow Studio, and down here, we wanted a map state, this one. And inside of the map state, we wanted Dynamodb put item. And now let's have a look here. Dynamodb put item. Integration type optimized, yada, yada, yada. That's all good. Next state, go to end. That's all good. And the input, it should all be good. Let's apply and exit and just see if it works. I gotta save it. Save anyway. And let's see if it works. I'll upload the file again. I'll upload the file again. I'm not sure if it works. So that's, here we go. So, Christoph, we can do two things because it's really distracting, and it probably is distracting the chat as well. This is an English language stream, and if you don't want to speak English on the chat, I will probably have to time you out. If you're fine with that, please go ahead. If you're not, please stop. Thank you so much. Okay, good. So it's successfully uploaded the file. Let's have a look at the execution. So we've got a failed execution again, and that is what I expected. So let's see, where did it fail? Execution failed. Oh, reference path must point to an array. Let me see. Let me pull up. Twitch real quick. Twitch TV. I usually don't feel it's necessary to blog anyone on my stream. Where's my channel? However, in some cases, here we go. All right. I think a timeout is good for now. All right. Okay, cool. So it doesn't work. Reference path must point to an array. And I'm not entirely sure if I need to add in the runtime in the state machine definition. I might have to. Let me see. I might have to add. I don't need that. I might have to add a reference. So here's the map. And what I want to use is just the thing, just the node itself. That's the node containing the array. And that's in the, was it payload? Let me see. I'll open up that in another tab real quick. So, all right, we have the execution. Now, wait a second. I'll go back to this one. Go to the succeeding execution. Have a look at the output of this one, and it contains a payload. All right, so I need the payload. Apply an exit, save anyway. Let's try again. Upload file, video stats, data, YouTube, upload. And for everybody who doesn't have an issue with me speaking English, if you like this channel, please, or at least make sure you like the video if you're on YouTube. Follow me or subscribe to the channel if you're on YouTube or Twitch. I'm running regular sessions talking about AWS, building things on AWS. It's a great place to learn, even for myself. So I just uploaded it. Let's go back to the executions. Let's see. Probably my session is done. Let me renew my session. Yep, the session is done. Let's reload. Here we go. This is it. These are the executions. It has failed again. All right, it has failed in here. 45 are still in process. 11 have been canceled. 1 has failed. Step output, step input. All right, so there's some issue here. I'm not entirely sure what it is. It starts the iteration. It tries the put item. Let me see if we find a failed state. No, we don't. Load more. Task aborted. Let's have a look. Map iteration item aborted. Task state aborted. All right, and this is something that I would have to troubleshoot, and now it's time to finish the session. So I'm really sorry, but it doesn't matter. I won't be live next week because there's reInvent next week. And if you don't know about reInvent, or if you're not registered with reInvent, this is something that you really should have a look at if you're interested in AWS. I'll just post the link, reInvent 2021. There we go. Where there will be a lot more about AWS. I will do a number of shows as well, but not on Twitch and YouTube. So if you want to join that, feel free. I'll be back the week after next. Thank you so much for joining. Yeah, next time we'll make sure that this map iteration works as well. Thank you for joining. I wish you a great weekend. My name is Dennis. I'm a developer, blah, 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 and that's it. I'm a developer advocate with Amazon Web Services. Thanks for watching. See you next time. Goodbye.